Okay, now we're going to solve by using square roots. So I know I can solve using square roots when I only see one thing squared, so just x is squared, and there's no other x. So if we had, thinking about our standard form, so if I have x squared and x, then I know I'm going to be factoring or completing the square. But when I see that it's just something with x squared or a parentheses squared, I can solve with square roots. So that's what we're looking for. So x squared, so something with just x squared or just some parentheses squared. So let's start with number 3. Okay, to solve using square roots, we're trying to get what's being squared alone on one side of the equal sign. So 4 is not being squared, just x is being squared. So I would do adding, subtracting first, and subtract 1 from both sides. Okay, and then now to get rid of this 4 next to the x, it's 4 times x, so the opposite would be dividing. Okay, so 324 divided by 4 is 81. And then now x squared is totally alone. So my last step is to solve using the square root. When I take the square root of x squared, it cancels out the square. So I'm just left with x. Anytime you solve with square roots, you need to make the answer, what you took the square root of, a positive or a negative. And then square root of 81 is 9. The reason for that is because positive 9 squared would give me 81, but we can also have negative 9 squared, and when that squares it would be also a positive 81. So that's why we have to show it could be positive or negative for the answer. Okay, so number 6 is a little different. Now we have a set of parentheses squared. So we're trying to get that set of parentheses squared alone on one side of the equal sign. Again, I'll start with adding, subtracting. So I'll add 6 to both sides. So 4x plus 11 squared equals 256. Now to get rid of this 4, I would divide it out. Never distribute 4 into a parentheses squared. Okay, you cannot do that. If you were to do that, we'd have to expand it, do FOIL, and then distribute 4. But here we're just trying to get this parentheses squared alone. So I'll divide both sides by 4. Okay, and we'll write it over here. So I have x plus 11 squared equals 64. Okay, so now I have just my parentheses squared on one side, which means I can take the square root of both sides. When I take the square root of an expression, it just cancels out the square. This stays the same as x plus 11. Square root of 64 is a perfect square, so it could be positive or negative 8. So the last step will be subtracting 11, but we're subtracting 11 from two different numbers. We have positive 8 and we have negative 8. So I write it out twice so I can see that I'm subtracting it from positive 8 and I'm subtracting it from negative 8. So when I subtract 11 from 8, I would get negative 3, and subtracting 11 from negative 8, I would get negative 19. And those would be my two answers. Let's take a look at one more, number 12. So number 12, there's no addition after my parentheses squared, but we have this 2 in front of it. So I'll first divide 2 on both sides. So I have x minus 7 squared equals 18. Now I solve by taking the square root, and then that cancels out what's being squared. So I have x minus 7, and then we want to simplify our square root. So this will be plus or minus, And 9 is a perfect square that can go into 18. So square root of 9 times 2 would give me 18. So just continuing over here, we have x minus 7 equals plus or minus the square root of 9 is 3 square root 2. So the last step would be adding 7 to both sides. In this case, I can't combine 7 with 3 root 2 because they're not like terms. So I'm just going to write this as with the 7 first, so that's the 7 I added, plus or minus 3 square root of 2. And that is two different answers, 7 plus 3 root 2 and 7 minus 3 root 2.